Um, this is a great event. The talks in this session has been amazing. What I want to talk to you today is a little bit, it's going to go against some of the talks that you have seen today. And I know this is end of the day. I'm not going to say anything technical. I'm not going to have more than 4 bullets in a slide. But I may ask you to use your cell phone. Great. Let's ask this intriguing question. We've been hearing about zero knowledge this entire session. Cost is an issue. Who's going to host it? Like, how long is it going to take? What GPU do I need to get? Who has the fastest prover? Here is a question I'm going to ask. What if zero knowledge proof costs go to 0? This is the technical answer. You can prove quickly, you can prove privately, and you can prove cheaply. But why should you care? Again, you've heard a lot today in the infra sessions. I'm not going to go on why, but with ZK, you can launch arbitrary L2s, fast, quickly, cheaply. It's going to give limitless scalability to Ethereum or any of the other L1s. It's going to solve interoperability. Come ask me later how that's going to work. Because with ZK, you can prove things that you want to before things happen. And finally, you can do arbitrary computation off-chain. I don't know if you saw Bobby's talk, was it Bobbin's talk in the morning or in any of the other sessions. He had a similar message. You'd be able to do arbitrary, very large computations off-chain. So this week, actually, we unveiled our zero-knowledge platform. And I thought, let me just start with a demo. So this is our platform where today you can log in. You don't need to come contact me. You can go to this web page, and you can build a zero-knowledge application today. And let me show you how easy it is to build an application. So I've created a few. I'm not going to type a program over here. So we are a zkVM, which means that you can use C, C++, Rust to build these applications. You can take a C program, drag and drop into the browser. You hit compile, and then you can prove. You have to give some inputs, and this proof is completely generated within the browser. And then, if you like it, you want to show it to your friends, you deploy it to the marketplace. You go to the marketplace, you can find it there. I'm going to pick another application, and I'm going to prove. Now, anyone, even if you don't know how to code any of these things, you want to build an application and then show it to other people, show it to your grandmother, show it to your friend who doesn't know zero knowledge, they can go to this site and just hit prove. And they would have generated a zero knowledge proof. And now, let me tell you something more interesting. I got a really powerful machine just before coming, just to show that what we can do on our just from a browser. I want to say everything that I'm doing here is from a browser. And I'll give you some context for here. If you know Ethereum and you know how a little bit of cryptography, what this number says is that I've generated 20,000 Poseidon hashes per second on my M4 laptop. Now, I want to say each of you, if you have a cell phone, etc., you can run this speed test. If you have iOS devices, you need to enable web GPU because we use web GPUs, but you'd be able to see how fast your device can prove our zero-knowledge system. So that's our platform. So let me tell you a little bit more about what we want to do at Ligero. I am a cryptographer. I've been studying zero-knowledge multi-party computation for about 2 decades. My vision is to build useful and usable privacy tools with zero infra cost. I know this goes against what we heard in this entire thing, but let me clarify what zero infra cost means. I want to say zero additional infra cost. You have an infrastructure, you can deploy the zero knowledge proof on your web server, on your mobile phone, on your laptop. Another focus I want to say, again, not criticizing anything. Much of the zero-knowledge applications you heard today, as well as that's running on scale today, is not about privacy. It's about verifiability. Today, privacy comes with trade-offs. There is trade-offs with respect to compliance, which people in enterprise care. There is trade-off in terms of cost. Do I need to get a 4090 GPU to run a zero-knowledge? Privacy, again, comes with usability. Is it easy for me to build and deploy this application? How easy is it to build? How easy is it to deploy? Do I need to learn a new programming language? And finally, privacy is traded off for trust. You have to trust someone else. If I need to do a sensitive computation, you need to think, I don't know, not twice, maybe 10 times before you're going to put it on a prover network. You want it on a device that you trust, you care, that you protect. Modern ZK does fall short on this. They require huge memory, which is why they need big devices, big RAM, and heavy hardware. The start-based ZK, again, they've done phenomenally in terms of improving scalability on Ethereum, but they don't run client-side yet. And again, it's because the way Starks are done, you can come and ask me technically why it is not memory efficient. Most ZKs are built only for verifiability, and it's not that they cannot be ZK, they can be, but they don't need to be, so they don't put it in their system. So this is something that they need to do in addition to what they're already doing. And they'll have to go through the security audit, et cetera, et cetera. And there are brilliant companies that are trying to give privacy-focused ZK, Aztec, Alio, Mina, Zcash, et cetera. But they require specialized toolchains. You got to learn their programming language. And as is customary, there is some Vitalik tweet that is relevant to the occasion, where he says that privacy use cases haven't reached client-side proving because they can't do anything beyond Merkle branches. We want to challenge this, and we are challenging this understanding or capability of client-side proving. For us, so I want to tell you what useful and usable means. Useful for individuals means client-side proving. I want to prove things about my identity, ZK email, ZK TLS. These are brilliant applications that are coming. I also, Europe is going to a digital ID. And, the current system, I want to say, just sucks. I mean, they need to use zero-knowledge proofs. Otherwise, it's not private. Privacy for organizations, which is scalable privacy, can be enabled through zkValidiums. Actually, ZK Sync had a beautiful proof of concept that they did with UBS just with this idea. Usable privacy. You want a standard toolchain. You want any developer to come and build this application. You want affordable hardware on your device. It doesn't get more affordable than that. You want to be able to run on any device. And, CUDA, NVIDIA, they're great. You're going to get a lot of scalability. But will it run on a metal? Will it run? Do I have to code again? And one of the decisions we took when we implemented, we could have gotten more performance out of writing it in CUDA, but we focused on using web GPUs so that it can run on any device. And finally, this has always been, again, from my research, but also what we do at the company, privacy is default. It's not like I have to go and set something so that it becomes private. Ligetron, this is the only technical slide. If you want to zone off, it's okay. I'm just going to quickly tell you. We are a zkVM. We use WebAssembly. Again, we are going against the grain. Everyone uses RISC-V. We use WebAssembly. I can tell you why WebAssembly is better, but I won't bore you here. We are ZK by default, we use web GPUs, and we are hash-based. This is important. I don't know if you watched Anikit's talk earlier today. Hash-based is thousands of orders of magnitude faster than public key-based. And that's why Starks are faster than any of the other systems, because they are hash-based too. And we are hash-based too. Just a minor slide in comparison, and again, I will tell you, comparisons, take it with a grain or a bucket of salt. This, we kind of try to run things on like a browser. I want to say Circom, again, they did amazing work. They were the first to really even do this with the language, etc. The Ident3 team did it, but they're not going to run client-side. They need a huge proving key. Noir, they are really getting into client-side proving. We benchmarked theirs on an M1 MacBook on a browser. They're somewhere around the 44 kilohertz. The Ligero system today on an M1 MacBook, depending on the circuit complexity, it can be anywhere between 250 kilohertz and 1 megahertz. And on this M4 that I recently bought, it goes up to 6 megahertz. That's about, in peak performance, this is about 27,000 hashes per second. And I had to quickly change slides today because Vitalik just posted saying that they want to move to Poseidon hashes for Ethereum, right? And you can now imagine, if this does happen, like our tech can power real-time proving from the browser because you've moved to Poseidon hashes. This is the last slide. This is our roadmap. Really what we want to solve is privacy applications. Privacy for individuals by solving identity, privacy for organizations through zkValidiums. And the next phase, it's not just that we want to allow coding in C, C++, Rust, or any of these languages. We want to benefit from all the development work that's been done here. There's so much like optimized circuits in Circom, in Noir, in Cairo. We want sort of cross-link any of these languages and be able to prove it through Ligero. You don't have to rewrite like optimized circuits for BLS signatures or ECDSA or EDDSA. It should just be an API call that you can do. You can code it in C++ or in Rust or in any other language. And we're not going to stop with that, right? There is AI. There are zkML. How nice would it be if you could just drop an Onyx code, which is one of the standard formats for ML, just on a browser and be able to prove it? This is sort of what we are thinking. Build anywhere, build in any language, deploy everywhere. Thank you.